We're doing how rate of change works in business and how we see the mathematics involved and how carefully we need to read. So, how does it apply in our business world? Here we have uh, an income. All right. If $1,100 is invested in an account that pays 4% compounded annually, the total amount A of T in the account after T years is this function. Notice T is the exponent. We want to, first for the A, find the average rate of change. Okay, so that means we have a closed interval from 0 to 5. All right, so we need to find A of 5 and A of 0. All right, so let's do the A of 5. Because then it's for 5 years. So we have 1100 times 1.04 raised to the 5. We're going to use our calculator for that. Uh-oh. Sorry about that. Got it showing the steps, so let me close that and reopen. There we go. All right. So we're going on our home screen, and we're going to enter the 1100. Oops. Sorry about that. Times 1.04 raised to the 5 years. And I get 113. Yeah. 1338. And 31, say 32. Right. Yes. This is what's in the account after the 5. At 0, I'm going to have 1100, 1.0. So I'm going to have anything to the 0 is 1. So I'm going to have 1100. So now that I have my values, I wanted to find the average rate of change. I want A of 5 minus A of 0 over 5 minus 0. All right. So I'm going to put in my values. 1,33832 minus the 1100 of the initial over 5. Let's see what I have. Sorry about that. Two 32 divided by 5. So that's an approximate, because we're going to divide by the 5. And the rate of change is 47.66. Well, we could say 47, whatever. For the sake of this lesson, we're going to go with that as our average. And now it says B. Find the average rate of change per year of the total amount of the account for the second 5 years of the investment, from 5 to 10. All right, so we want F of 10 and F of 5. Okay, now we know what 5 is because we said that was 1, 3, 3, 8, 3, 2. So we need F of 10. Get our calculator out. And we want 1100 times 1.04 up caret 10. I'm going to have 162827. Okay. So now I'm going to structure my rate of change. 162827 minus the 133832 from, and this is from 10 minus the 5. So 1628.27 minus the 1338.32, 28995 divided by the 5. All right, so I'm going to hit divide 5, and I'm going to get 57.99. All right, now what we have here is compounding. So you can see that as we get further into the savings, we're making more in average of the income. Now it says C, estimate the instantaneous rate of change. Instantaneous rate of change. So, at 5. So we're going to take the limit as h approaches 0. And we can use the value, but it's very difficult to do the exponent on it. So let's go ahead and work this out. Let's see what we have here. So I'm going to have well, this would be hard to do. So we would probably look at a table to find this particular one because we have an issue here of what we can do, and we're going to drop in our value. Well, let's drop in our value. Let's see what we can do. And this we already know what it is because this is at 5. 1138 1338 H. All right. So you can see that in this scenario, as what we have is kind of difficult to do. And we can see the change in this as H approaches 0. And I think we'd have to go with a table on this guy. All right, so we're going to do, as we get approaching what we want, which is 5, the instantaneous rate at 5, before and after. All right, and make it small increments. So we want, before the 5, we want on our table for x, we want decimal, and we're getting closer and closer. So we want 4.9, 4.99, 4.999, and then we could take the limit at 5, but then we're going to do 5.100001 and 5.00001, and so forth. So let's look at our table on that, because I cannot do that math without going into the short form of what we have. So I'm going to go into my y equals, I'm going to clear it, and I'm going to enter my formula, 1100, parenthesis 1.04, close parenthesis, up caret x. All right. And I'm going to go to the table. So I'm going to go second window, and I'm going to ask for the independent. But don't ask. And now I can do second graph and put in the values of what I want. 4.9, 13331, 4.99, getting closer, right? 13378. And then I'm going to do 4.999, and I'm going to get closer. 1338.3. I'm going to do 5, but I'm not going to enter the 5. 5 is 1338.3, which is the same as the 5999. Then I'm going to do 0.5001, and I get 13383, and I think if I go here, I got a whole bunch, 1.32. Let me go up one, and this one is 3.2. You can see that already I'm at that rounding point. All right, so let me do, 5.00001, and I get the same thing. So we can safely say that it is what we got as the limit at that instantaneous rate of change. Oh, that problem was long, so I'm going to stop there, and this was on average rate of change.